Okay guys, this is lesson number 103 for Algebra 1. So here is your assignment. Make sure you pause it and get that down. Okay, I know that we've already covered this lesson in class, but it's been over a week. And so I'm thinking it would not hurt anybody for us to go back through this list. It's not a list, to this lesson. Okay, so 8.4, the slope-intercept form of a linear equation. What's the objective? What are we trying to get out of this lesson? To use the slope-intercept form of a linear equation. Now, before we keep going, you got to remember what is the standard form. That's the thing I made you memorize in class. Do you remember? AX plus BY equals C. If you see something in this form, it'll be a line, and we call that the standard form. Now, we're going to also introduce in this lesson, or review, the slope-intercept form. So we're going to have two things, and you have to memorize these. You really do just need to know both of these things. Well, it's going to look like this. Y equals mx plus b. These b's are not the same, so don't get that mixed up. This means slope, and this means y-intercept. Okay, let's look at the book. The points with coordinates -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4 are on the graph of the linear equation y equals 2x. Okay, let's make sure we're tracking. So -1, 2, 1, 2, 3, 4. There's -2, -4. -1, -2. There's that point. 0, 0. 1, 1, 2 is on there, and then 1, 2, 1, 2, 3, 4. So all 1, 2, 3, 4. 5 of those points are on this graph, and if you draw a line through them, it is the equation y equals 2x. What's the slope? Well, you pick one of the points, it goes over 1 up 2. So remember, do you see how they made it colors? That's nice. So the blue is the up and down, or we call it the rise, and it goes on the top. And then the red is the run, how far it goes over. So the slope is 2 over 1, and it passes through the origin. Now, if you look at this graph, y equals -1/3 x. It has this graph, and it passes through the origin. So this is what we have to learn, this gray box. For every real number, m, so they're just using m as the letter, and any number m that has this as an equation, y equals m times x, it's going to be a line. If you see y equals a number times x, it's going to be a line, and the slope of that line is going to be m, and it's going to pass right through the origin. So here's what we're talking about. If you see this, y equals 5x, is that a line? Yes, because it has y equals something times x. Is this a line? -0.2x. What about that? Yes, all these are lines because they all look like y equals a number times x. Now another question. What is the slope of this line? 5. Remember, if it's a whole number, you can change it to a fraction like this. So this would be a rise of 5 and a run of 1. A rise of 1 and a run of 2. So up 1 over 2. Now, whoa. This is still a slope. This is still a slope. We would have to change it to a fraction to make some sense of it for a rise over run. -2/10, -2/10, or simplify it, -1/5. Okay, does that make sense? These are all lines, and this is the slope. Let's keep going. The graphs of the linear equations y equals 2x and y equals 2x plus 4 are shown at the right. The red line is y equals 2x. It's the same as this black line, but they made it down here and made it red. And then y equals 2x plus 4 is this blue line. Notice the lines are parallel. They have the same slope, but they cross the y-axis at different places. The y-axis goes up and down. Let me scoot this up a little bit. The y-axis goes up and down. So the red line is here. The blue line is here. The red line crosses it at the origin. The blue line crosses it at 4, 0, 4. The y-coordinate of a point, so this is the x-coordinate, this is the y-coordinate. The y-coordinate of the point where graph crosses the y-axis is called the y-intercept. So what's the y-intercept of this line? 4. What's the y-intercept of this line? 0. Get it? So you look at the point where it crosses the y-axis, and you say what the y of it is. 0, 4. Okay, good. Got it? Oh, there it is. You plug in 0 for x, and it will tell you what the y-intercept is. And look at this, look at this. Y equals mx plus something. Y equals mx plus something. That something that you add is the y-intercept. So look here, gray box number 2. For all real numbers m and b, so m and b, y equals mx plus b is the line with a slope of m and the y-intercept of b. This form of a line is called the slope-intercept form. So now, there it is. One more time. We have the standard form of a line, ax plus by equals c. And the slope-intercept form, y equals mx plus b. M is the slope. B is the y-intercept. Okay, let's see if we can use this and make some sense of it. Okay, example number 1. It says, find the slope and y-intercept of this line. Okay, so look right here. Y equals 3/5 x plus 2. You should be able to look at this and instantly say what the slope is. What's the slope? 3/5. 3 over 5. Now, what's the y-intercept? 2. The thing that gets added is where it crosses the y-axis. There it is. For y equals 3/5 x plus 2, we have m equals 3/5. The slope is 3/5. And b is where it crosses the y-axis. 2. B is 2. There's the answer. Okay. Example number 2. Let's see what we can make. Keep going here. Now, suppose they give you the slope-intercept form of a line and they say graph it. Okay, you can do this so fast. Watch, 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 watch. Let's write it down. So y equals, let's go here. So y equals negative 3/4 x plus 6. Okay, now, you recognize what? This is the slope-intercept form. There it is. Okay, slope-intercept form. That means that this is the slope and this is the y-intercept. So if I have my graph paper, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can take this number, and remember, this is the number where it crosses the x-axis. I mean, the y-axis. So here's the y-axis. 1, 2, 3, 4, 5, 6. I'm just going to go like that. 6. 6 up. Now, negative 3/4 is my slope. So I'm going to start here and go down 3. 1, because it's negative, so I'm going to go down. 1, 2, 3. And then I'm going to go to the right 4. 1, 2, 3, 4. I just graphed. Whoa, it's an amazing line. I just graphed this equation. See how it works? You start with the y-intercept, put the dot, count the up-down part, the rise. If it's negative, you go down. If it's positive, you go up. And then you go over to the right. Okay, let's do another example here. This last example, the second to last example, excuse me, asks you to use only the slope and the y-intercept to graph this. Now wait a minute. What do you notice about this particular equation? 2x minus 5y equals 10. This is the standard form of an equation. Notice it looks like ax plus by equals c. It's not slope-intercept form. We are going to transform it to make it look like y equals mx plus b. We're going to transform this thing. Okay, so here's how we're going to do it. We're going to make sure all the x's and the numbers are over here. So minus 2x minus 2x. So now I have negative 5y equals 10 minus 2x. I want the x part to be in front of the 10, so I'm going to rewrite it. Make sure you keep the negative. Okay, now we're almost there. I need the y to be by itself, so I'm going to divide both sides by negative 5. Negative 2x divided by negative 5 is 2/5 x. 10 divided by negative 5 is negative 2, so I'm going to do minus 2. And there's my answer. But they said to graph it, so I'm going to do the same thing I did before. I'm going to get my graph. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Negative 2 comes from right here. I take the y-intercept, and I go, since it's negative, I go down 2, 1, 2, and put my first point. Then I look at my slope, and I'm going to go up 2, 1, 2, and over 5. 1, 2, 3, 4, 5. Now I have my line, and I graphed it only using the slope and the y-intercept. I had to transform the equation first. Okay, see how that works? All right. Okay, this little box down here is kind of important. It says different lines with the same slope are parallel. Parallel lines don't intersect. So if you see that a line has the same slope as another line, they're parallel. Okay, flip the page. One more example here, and then we can start the homework. Okay, it says, show that the lines with the equations 2x plus y equals 8 and 2x plus y equals 6 are parallel. Well, how are we going to do that? You're going to transform this equation into the slope-intercept form. And you're going to transform this equation into its slope-intercept form. Then look at the slopes. Negative 2, negative 2. They are the same. Okay. So if the slopes are the same, what do you know about the lines? They're parallel. If you have same slope and different y-intercepts, they're parallel. Think about this. What if they had the same y-intercept? They'd be the exact same line. Okay, that's it, guys. We did lesson 8.4. I went over it again just in case. You're going to do the second half of the assignment. If you have any questions, just get a hold of me, and I'm going to do a new video going over 8.5.